Chapter 5 Ethernet. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts and an Ethernet network, the host formats the message into the frame layout that is specified by the standards. Because Ethernet is comprised of standards of these low layers, it may be best to understood in the reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standards define both the Layer 2 protocols and the Layer 1 technologies. Ethernet encapsulation. Ethernet is the most widely used LAN technology today. Ethernet operates in the data link layer and the physical layer. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet supports data bandwidths of 10 MBS, 100 MBS, 1000 MBS to 100,000 MBS. LLC sublayer. The Ethernet LLC sublayer handles the communication between the upper layers and the low layers. This is typically between the networking software and device hardware. The LLC is implemented in software and its implementation is independent of the hardware. In a computer, the LLC can be considered the driver software for the NIC. The NIC driver is a program that interacts directly with the hardware on the NIC to pass the data between the MAC sublayer and the physical media. The MAC sublayer consists the lower sublayer of the data link layer. MAC is a MAC is implemented by hardware, typically in the computer NIC. The data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer PDU. Data encapsulation provides three primary functions. First, frame delimiting. Second, addressing. And third, error detection. Frame delimiting is the framing process provides important delimiters that are used to identify a group of bits that make up a frame. These delimiting bits provide synchronization between the transmitting and receiving nodes. The addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. Error data connection. Each frame contains a trailer used to detect any errors in transmissions. The use of frames aids in the transmission of bits as they are placed on the media and in grouping of bits and receiving node. Media control. The second responsibility of the MAC sublayer is the media access control. Media access control is responsible for the replacement of frames on the media and the removal of frames and from the media. As its name implies, it controls access to the media and the sublayer communication directly with the physical layer. Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence or FCS field. The preamble field is not included when describing the size of a frame. MAC address and hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits. Just as decimal is a base 10 number system, hexadecimal is a base 16 system. The base 16 number system uses the number 0 to 9 and the letters A to F. Given the 8 bits is a common binary grouping binary can be represented in hexadecimal as the range 0 to 0 to FF. Note: it is important to distinguish the hexadecimal values from decimal values regarding the characteristics 0 to 9 as shown. Representing hexadecimal values. Hexadecimal is usually represented in text by the value preceded by 0 times, or subscript 16. Less commonly, it may be followed by an H, for example 73H. However, because subscript text is not recognized in command line or programming environments, the technical representations are hexadecimal. In Ethernet, every network device is connected to the same shared media. Ethernet was once predominantly a half-duplex topology using a multi-access bus, or later Ethernet hubs. This meant that all nodes would receive every frame transmitted to prevent the excessive overhead involved in the processing of every frame. MAC address structure. The MAC address value is a direct result of IEE enforced rules for vendors to ensure globally unique address for each Ethernet device. IEE requires a vendor to follow two simple rules. All MAC addresses assigned to a NIC or other Ethernet device must use the vendor's assigned OUI as the first 3 bytes. All MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. Unicast MAC address. Unicast MAC address is the unique addresses used when a frame is sent from a single transmitting devices to assign the single destination devices. Broadcast packet contains as destination IPv4 addresses that has all ones in the host portion. This numbering in the addresses means that all hosts on the local network will receive process and the packets. Many network protocols such as DHCP and ARP use broadcast. Multicast MAC addresses. Multicast addresses allow a source device to send a packet to a group of devices. Devices that belong to a multicast group are assigned a multicast group IP addresses. Multicast addresses would be using in remote gaming, where many players are connected remotely but playing the same game. Another use of multicast addresses is in distance learning through video conferencing, where many students are connected to the same class. Learning MAC addresses. The switch dynamically builds the MAC addresses table by examining the source MAC addresses of the frames received on a port. The switch forwards frames by searching for a match between the destination MAC addresses in the frame and the entire entry in the MAC's access table. The following process is performed on every Ethernet frame that enters the switch. Learn examining the source MAC addresses. Every frame that enters the switch is checked for new information to learn. It does this examining the frame's source MAC addresses and port number where the frame entered the switch. Frame forwarding methods on Cisco switches. Switches use one of the following forwarding methods for switching data between network ports: store and forward switching, cut-through switching. In store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. During the storage process, the switch analyzes the frame for information about its destination. In this process, the switch also performs an error check using the cyclic redundancy check, trailer portions of the Ethernet frame. CRC uses a mathematical formula based on the number of bits in the frame to determine whether the received frame has an error. After confirming the integrity of the frame is forwarded out the appropriate port towards its destination. Cut-through switching. In cut-through switching, the switch acts upon the data as soon as it's received, even if the transmission is not complete. The switch buffers just enough of the frame to read destination MAC addresses so that it can determine to which port forward the data. There are two variants of cut-through switching: the fast-forward switching and the fragment-free switching. For the fast-forward switching offers the lowest level of latency. Fast-forward switching immediately towards a packet after reading the destination addresses. because fast forward switching starts forwarding before the entire packet has been received. There may be times when packets are relayed with errors. This occurs infrequently, and the destination network adapter discards the faulty packet upon receipt. The fragment-free switching, the switch stores the first 64 bytes of the frame before forwarding. Fragment-free switching can be viewed as a compromise between store and forward switching and fast-forward switching. The reason fragment-free switching stores only the first 64 bytes of the frame is that the most networks errors and collisions occurs during the first 64 bytes.